This melodious sound is not being played by any musical instrument, but is being emitted by a miracle device known as hydraulic ram. In fact, this simple machine has transformed lives of many people in Kabri district. The Center for Rural Technology, in collaboration with Water Mill Association of Kabri district, has been installing and operating these pumps. Despite being in a proximity to abundant water sources, most of the villages on the hilly terrains of Nepal face acute water shortages. Women and children struggle and spend several hours a day fetching water. This means wasted time, wasted productivity, and the underutilization of otherwise productive lands. The hydraulic ram pump seems to be an appropriate technology for such difficult terrains. The Center for Rural Technology, CRT, has been promoting this technology. A non-governmental organization established 25 years ago, CRT is actively involved in researching, developing and promoting appropriate rural technologies in Nepal. It is primarily engaged in alternative energy sectors. What is a hydram? A hydraulic ram pump, also known as hydram, is an automatic pumping device which utilizes a small fall of water to lift it to a much greater height. Except for running water, it does not require any external source of energy. These pumps, therefore, can be installed and operated anywhere in the country for lifting water, for drinking and for irrigation purposes. How do hydrams work? At first, water from the sources is directed towards the pump through drive pipe. When water enters into the pump, the waste valve closes due to pressure. This creates high pressure in the chamber. Because of this, check valve opens and water rushes into the air chamber. The compressed air then forces the water downwards. This action closes the check valve and water is diverted into the delivery pipe. Then pressure drops in the pump chamber, which in turn opens the waste valve. This allows the water to flow outside. This cycle repeats and the pump operates continuously. Benefits of hydram. Some major benefits of hydram are efficient and sustainable solution for water supply in villages in hilly areas. Reduces drudgery for women and children who are tasked with collecting water. Saves time which can be spent on more productive uses such as livelihoods and studying. Supports livelihoods such as vegetable fruit farming, cattle rearing, fisheries and biofertilizer production. Reduction in illness and disease by enabling better hygiene and sanitation. The women feel empowered through participation in economic and social activities. Environmentally friendly and benefits from not having to buy fossil fuels. Despite being a simple device, it cannot be installed everywhere. The vertical distance between the main water source or the canal and the pump must be at least 1 meter, and the pump has to be installed at the downside. Similarly, the vertical delivery height from the pump to the supply point must be a maximum of 150 meters for drinking water supply and a maximum of 70 meters if it is for irrigation purposes. The pump size also varies. It depends upon community needs, geographical situation, and quantity of flowing water available at the source. Depending on these factors, pumps from 1 inch to 4 inches diameter are used. During the installation of hydram, some physical structures also need to be constructed. This includes constructing a wire at the main water source, canal and pipeline systems. It also includes construction of a reservoir tank and community water distribution system. A drive tank also needs to be built along with a pipeline connecting these structures. A pump house in order to shelter the pump may also be needed. Though hydrams need minimal care, periodical checkups and maintenance is necessary. While in operation, leaves and other debris must be prevented from entering the pump. Otherwise, the pump has to be opened and the particles removed. Because of its continuous motion, nuts and bolts usually tend to loosen. Therefore, it must be ensured that they are tightened on periodic basis. Hydram's waste valve must also be replaced every 6 months and the hinges every 3 months. Because it demands regular supervision and maintenance, it is advisable to have the system maintained through a community trust. The Center for Rural Technology has already introduced this technology in 7 districts at 18 different locations. In Balthali 5, Nepani Sanagaon of Kabri district, CRT has installed a 4-inch hydram system for irrigation purposes. In Dhunkharka Ward number 2, a similar system was installed for drinking water supply. Likewise, in Dhumkharka 9, a multi-purpose 4-inch hydram was installed. And in Songkhu village, a 3-inch pump was installed to lift drinking water. Use of this technology has brought about many positive social and economical changes in these villages. The community participation has played a major role in the success of these projects. They had provided labor and local construction materials. In all, 62 households have been supplied with water for drinking and irrigational purposes. There has been a significant improvement in sanitation, and irrigation methods like drip irrigation and sprinklers have helped irrigate nearly 9 hectares of land, improving the overall agricultural productivity. Likewise, in coordination with local VDCs, 64 toilets were built as part of the program. For long-term use of hydram, skilled technicians are required. Local representatives were therefore given capacity-building trainings on repair and maintenance of hydram, along with basics of hygiene and sanitation, climate change, and water resource management. This technology can be a blessing to thousands of other villages in Nepal who are facing severe water shortages despite lying very close to rivers and other water sources. In those areas which lack electricity and where transportation of diesel and petroleum is difficult, this technology makes a wide range of agricultural productions possible and can help improve livelihoods of people by providing additional income generation opportunities.